All right, welcome to our webinar today on sports performance science. This is part 3 in our series, and we're talking about improving human performance and return to play with plantar pressure data analysis. Our key takeaways today are first, understanding how plantar pressure measurement devices and technology provide more than just pressure data. We'll learn about the primary data sets that can be obtained using plantar pressure measurement systems and the complementary technology. And we'll experience how to analyze plantar pressure data and gait info to monitor and improve athletes in sports performance. This is the third in our series of webinars. And today specifically talking about return to play and plantar pressure analysis. A quick overview after our introduction. We'll talk a little bit about XSENSOR's intelligent dynamic sensing platform, give an overview of the data output, talk about quantitative versus qualitative analysis, look at how it's not just the plantar pressure data that we're looking at, review center pressure progression, force versus time curves, the cyclogram, and finally 3-box analysis. I'm Bruce Malkinson, Chief Operating Officer and champion for our insole pressure mapping product, and I have joining me today international sports performance consultant Antonio Robustelli.
Hi, I'm Antonio Robustelli. I am a professional sport performance consultant and coach from Italy, working with athletes and teams all over the world specialized in sports technology application.
A little bit about XSENSOR technology. So for 25 years now, XSENSOR Technologies has been building pressure imaging systems with a focus on outstanding accuracy and quality for clinical applications, nurses and therapists trying to prevent pressure injuries in their patients, for vehicle interior and tire designers, as well as safety engineers, and finally in mattress retail for mattress designers and retailers around the world to help their customers get better quality sleep. And of course, all these technologies have been integrated in our latest product, XSENSOR's X4 Intelligent Insoles. Intelligent dynamic sensing, the evaluation of plantar pressure and gait, can provide key insights into optimizing athletic performance, and without it, those gains may never be realized. And existing plantar pressure and gait measurement systems are just not suitable for real-world testing in clinical sports performance or in research applications. This is why XSENSOR developed our intelligent dynamic sensing platform. Our intelligent dynamic sensing reveals accurate gait and motion data to help biomechanics professionals optimize human performance. Thank you, and with that, I will pass the mic to Antonio.
Okay, let's start with the overview of the data output in plantar pressure measurement. First question is, what are the main data output of a plantar pressure measurement system? We will focus here in this webinar in 5 main type of data sets. The first is the peak pressure image. The second is the center of pressure progression. The third is the force time and pressure time curve. The fourth is the cyclogram analysis. And the fifth is the 3-box analysis. Starting with the first type of data sets called peak pressure image. The peak pressure image is the first step in the plantar pressure measurement technology. Is the first step to take when starting to assess a player or an athlete with a plantar pressure measurement. Here you can see an example of what a peak pressure image is. It's basically an image of a foot, is a foot scan, is an image showing all the peak point of pressure during the stride. You can perform 2 types of analysis with a peak pressure image, qualitative and quantitative analysis. What is quantitative and qualitative analysis. A quantitative measurement is a measurement of data that can be put into numbers. Is a statistical analysis of performance markers. Qualitative measurement focus on collecting information that is not numerical. And a qualitative measurements look at movement patterns efficiency. Let's start with the qualitative analysis. By looking at the peak pressure image, the first thing to look at is identification of areas of high pressure. The second is looking at asymmetries in overall footprint. By looking at the image, you can just have a first insight into the symmetry in footprint between left and right foot. Switching to quantitative analysis, you can analyze contralateral and ipsilateral weight distribution, as well analyzing the orientation of the axis of the feet. What to look for in a peak pressure image? We have divided the type of analysis to do in 5 main markers and steps. We can look at the pressure at the heel. We can look at the pressure in the medial arch. We can look at the pressure under the first metatarsal head and the pressure at the hallux. We can look also at the overall loading of the forefoot and the shape or trace of the center of pressure that you can see identified by the gray line in the middle of the foot. Also, we can look for pressures under each segment of the foot. As we have seen in our previous episodes of this sports performance science series, one of the main features of a plantar pressure measurement technology is the ability to differentiate and isolate the foot, and due to the matrix configuration of the measurement technology, the possibility to divide and create segments of the foot and regions of interest. In this case, we are looking at rear foot, midfoot, and forefoot. But the pressure measurement technology is not just pressure data. I would like to stress this concept because sometimes people tend to think about pressure measurement technology as a way to look at pressure, but using a plantar pressure measurement system is much more than simply pressure, and we will see this in detail. This is a screen of the X4 foot and gait software, which is part of what I call X4 ecosystem, which is a series of interconnected elements. And so the software is the brain of this ecosystem. This is a screen showing the different type of data sets obtained with the gait or running task with the insoles. We can look and obtain, as I already saw you before, more than simply pressure data. We can obtain pressure values. We can obtain load and force values. We can obtain timing and time-related variables. We can obtain measurement about the center of pressure development. We can obtain information about different parts of the foot. We can use plantar pressure mapping for analyzing the effect of a show on an athlete. We can use this for show fitting. We can obtain spatiotemporal data, and we can also use it for training and retraining specific patterns as a real-time feedback and biofeedback tool. The second type of data set is related to the center of pressure progression. When analyzing the progression and the trails of center of pressure, we need to look at three main aspects: the trajectory, the starting and ending points of the center of pressure, and the timing. Trajectory, based on experience and clinical practical application, the center of pressure trajectory should be midline on the foot, okay, and starting from the heel to the second metatarsal head, like the picture shown in this slide. The starting and ending point. Looking at the starting and the ending point represented here in the picture, indicated by the green line, can provide coaches powerful information about propulsion, about early termination of propulsion and a late starting point, but in a ipsilateral and contralateral. Last thing to look at is the timing. The timing of progression of the center of pressure can help us in identifying difference in acceleration of the one segment of the foot respect to the other, and give us information about the timing in heel rise and the forefoot loading. The third type of data set to look at is the force time curve and pressure time curve. As movements occur over time, most of the analyses are related to movement relevant time intervals. In this case, we are looking at force time curves and pressure time curves. Let's look at this at the graph showed in the slide. We can identify, as you can see, the different phases of strike. The foot strike is the first curve in the graph, as you can see. The middle curve is representing the mid stance, and the last peak is the propulsion phase and the toe off. We can use this type of data and curves to make a bilateral comparison between left and right side, and also by analyzing the force time relationship and the duration at heel strike and toe off, if there is a delay, of if the timing of heel strike and toe off is similar between left and right side. Also, we can look at how the risk of injury can increase if the first peak representing impact forces is going to reach an highest level respect to the second peak. In a normal strike, the first peak should be lower than the second peak. This is another example. This is a pressure time curve. You can identify the foot strike phase, the mid stance phase, and the propulsion and toe off. You can look at how the left and right side are similar in terms of pressure application by analyzing the left and right peak pressure. You can see the first graph is showing the left and right peak pressure versus time. The second graph is showing the left toe, the segmentation, the left toe, metatarsal, midfoot, and heel. And the last graph is showing the right toe, metatarsal, midfoot, and heel. And each segment of the foot is represented by an isolated curve. This is another example of a bilateral comparison between left and right side. And you can see a first-time curve and looking at what is the timing of left and right side during the stance phase, and the peak of the two curves at foot strike and at propulsion and toe off. This is another example of how you can use the Pro Foot and Gait software to isolate different part of the foot. This is still a first-time curve. You can see on the left image with the left and right heel, and on the right image you have the left and right metatarsal and the left and right toe. You can isolate the forefoot, the heel, and analyzing them in relation to the entire foot, obtaining information about different foot segments, ankle, subtalar joint, and metatarsophalangeal joint. This is an example of a forefoot curve. The image, the first image is representing the left metatarsal and left toe, and the second picture is representing the right metatarsal and the right toe of two subsequent stances. By looking at the curve, isolated curve of the forefoot, we can identify limitus in the function and the mobility of the hallux. We can identify problems related to functional hallux limitus, and also we can look at how the function of the lateral and medial columns of the foot is working. Here you can see by looking at the forefoot curve and by looking at the timing of the left and right foot, you can see if there is a prolonged duration of forces and a lateralization of pressures at the forefoot. This can be a sign of a metatarsophalangeal joint mobility dysfunction, which is going to block the forward motion, and a lack of midfoot stability, which is usually can be identified by a delay forces in a forefoot curve. This is a heel curve. We have the left heel on the top and the right heel. When looking at this curve, we can identify an early heel rise, especially when we have a short and low duration curve. And this is a sign of a heel which is not fully lifted during striding. This can lead to a problem and a weakness in ankle joint dorsiflexion range of motion, and also in a lack of stability in the midfoot and forefoot, with becoming more compliant. This is the fourth type of data sets that can be used. It's the cyclogram, also called butterfly diagram. It is a graph showing the course of the center of pressure during selected step cycles. The cyclogram is a good indicator of center of pressure variability. because it helps understand how the center of pressure is changing over time during different strides. When looking at the variability of the center of pressure with the butterfly diagram or cyclogram, we can look at the lateral variability, which is depicted here in the y-axis, and the anterior posterior variability, which is depicted here in the x-axis. Let's have a look at the last of the main datasets that we are using with the plantar pressure mapping application in sport. The last one is the three-box analysis. The three-box analysis is a term, is a use to describe the ability to create a segmentation of the foot. In this graph, you can see an example of a three-box analysis. Here in the picture, you can see the curves for right heel, a right midfoot, a right metatarsal, and a right toe. By looking at this graph, you can easily identify how each of this segment of the foot is contributing to the overall function of the foot during the strike and during the mid stance and during the propulsion and toe off, trying to help driving better decision in order to optimize performance and rehabilitation. In conclusion, the three main aspects that you need to understand when implementing a plantar pressure mapping system for analyzing human performance and return to play is first that plantar pressure technology is not just pressure data. An insole system provides more than just pressure data, and you can view pressure values, load, timing analysis, center of pressure analysis, foot segmentation, spatiotemporal data, and much more. The second aspect is that we have 5 primary data sets. And capturing plantar pressure data with pressure measurement system can provide this data outputs such as peak pressure image, COP, center of pressure progression, the cyclograms, force time and pressure versus time curves, and the three-box analysis. The last aspect is related to how to interpret the data. Many of the key datasets and output included the insole systems like the force time curve and pressure time curve can provide critical information into an athlete's development and training.
Thank you so much, Antonio. And I would just like to invite everyone to join us for our next webinar in the series, which will be part 4, and that is plantar pressure measurement protocols with intelligent insoles for stance pads and walkway sensors. Thanks again. You can get in touch with Antonio at OmniAthlete Performance Concept and reach out to him at the address below. And thanks to everyone for attending. We invite you to get in touch with XSENSOR, schedule an online demo or a trial of our sensors, and you can connect with us at sales@xsensor.com.